Now we want to get a handle on the meaning of f of x plus delta x minus f of x. Well, here's f of x, here's f of x plus delta x on the y-axis. Now, consistent with what we saw over here just a little while ago, f of x plus delta x minus f of x could be represented by this arrow. So, there we have it. F of x plus delta x minus f of x is how much the value of x changes as x changes from x to x plus delta x. Okay? Now, one natural thing that we would ordinarily do anytime we have 2 points on a graph and want to think about the relationship of those 2 points is we will generally want to think, okay, is there anything that we could get from the fundamental triangle corresponding to these 2 points? And we know how to draw that triangle. Okay, so here's our triangle. Now, in class, somebody said, I said, well, once we have 2 points, what can we do? So I said, well, find the slope. That's good. That's good. I would say, first, the primary thing is this triangle, because this triangle gives you more than just the slope. As we've seen, you can reason in terms of this triangle to find the midpoint or the length of the hypotenuse. Okay? But in this case, it is the slope that we're really after, but we don't even have to think about that. Let's draw our fundamental triangle first, and then label the sides of this fundamental triangle. Well, let's see. This side from here to here is, well, we could do that. It's x plus delta x minus x, right? So, let's see. This arrow represents this. That's going to be x plus delta x minus x, but that just equals delta x, doesn't it? And it's kind of important to have that insight. That could be very relevant in some problems. So if we want to label this triangle, here we have delta x. Now what do we have here? Well, these dotted lines are all parallel, so that this displacement from here up to here is the same as this displacement here. So this is just f of x plus delta x minus f of x. And that would be the rise of the triangle. Now, this triangle, from this triangle, we can conclude what the midpoint, the slope, and the distance between the 2 points is. The specific thing we want to focus on here, now we could do that. Now, okay, if we had these 2 points, these coordinates, it would be a good exercise to go ahead and find all of these things. And I'll probably write all of them down in a minute, but the one we're going to focus on is the slope. Because as you should understand, the slope can represent a change in y divided by a change in x, which is a rate of change of y with respect to x. So the slope of the line segment from these between these points is what? It's rise over run which is f of x plus delta x minus f of x, because that is your rise, divided by the run, which is just delta x. Okay, so if we go from here to here, and here to here, our run is delta x, our rise is f of x plus delta x minus f of x. Okay, and that's the slope of the graph. Now this is the average rate of change of y with respect to x from x to x plus delta x.